Wide 80. Set hit. Ah!
Oh no!
My foot's broken. I think I need a replacement.
Oh no. Oh no. Oh no. Our starting receiver is hurt. Looks like I'm gonna have to come in. Let's go.
Wide 80. Omaha. Omaha. Set hit.
Alright, so here's the problem we were able to come up with. Due to Alex's injury, Nico is forced to come into the game. When Nico catches the pass from Sam, he takes off at a rate of 5.71 yards per second. Josh, the defender, is situated 17 yards to the left of Nico and 10 yards downfield. He begins backpedaling at a rate of 3.64 yards per second. After 2 seconds, Josh changes direction and runs perpendicular to the sidelines at a rate of 6.45 yards per second. Find the rate at which the distance between Nico and Josh is changing at 2 seconds, part A, and at 4 seconds, which is part B.
Well, after the pickup game, we thought it'd be really cool to turn that into a related rates problem. So here's the basic setup of the problem. I, as the wide receiver, started here, approximately 17 yards away from Josh, to the left. Josh was also 10 yards upfield, and I was running at a rate of 5.71 yards per second, while Josh was backpedaling at 3.64 yards per second. The first part of the problem is to find the rate at which our distance was changing after 2 seconds. So after 2 seconds, I traveled 11.42 yards, and Josh was 17.28 yards away from me. So I'll hand it over to Sam now.
And then our variables we get for the problem, we get 17 from the distance between Nico and Josh at the beginning. X prime is 0 because that distance horizontally is not changing at all. We get Y from the distant from since Nico traveled 11.42 yards and Josh from the last scrimmage, and Josh traveled 17.28 yards from the last scrimmage. You subtract those two to get 5.86. And then with their rates, since they're traveling in the same direction, you subtract the rates from each other, and the difference between those was 2.07. And then to get Z, you use the Pythagorean theorem, and we found out it was 17.98. And what we're solving for is Z prime.
Okay, so now that we have all our variables except for Z prime, which is what we're looking for, we can then again use the Pythagorean theorem, but we have to derive it. So to derive it, you just do how you derive. It's 2x x prime plus 2y y prime equals 2z z prime. So the 2's can cancel out, and you're left with x prime plus y prime equals z prime. So then you just divide z by both sides, and you get z prime by itself, which is what you're looking for. So now you have the equation to find z prime. You plug in your numbers, and you get 17 times 0, which is 0, plus 5.86 times 2.7 divided by 17.98, and that leaves you with 0.67 yards per second, which is z prime.
And now for the second part of our problem, we are solving for at what rate the distance is changing after 4 seconds. And after 2 seconds, Josh gets out of a back pedal and starts running horizontally at Nico, giving us this triangle right here. And what we're solving for is how fast the rate at which this distance is changing.
We're going to start by writing down all of our known variables. For x, we have 4.1 yards because Josh and Nico started 17 yards away, and Josh traveled 12.9 yards. So the difference of that is 4.1. X prime is negative 6.45 yards per second, as that is Josh's rate, and it's negative because he's traveling towards the point of reference. Y is 5.56 yards. That's just the vertical difference between Josh and Nico. And Y prime is 5.71 yards again, as Nico is traveling the same rate as he was in the first part of the problem. And for Z, you solve Z by doing the Pythagorean theorem, and you end up getting 6.91 yards.
Alright, now we have to derive the Pythagorean theorem using the power rule. So we'll take 2x x prime plus 2y y prime equals 2z z prime. So the 2's cancel out, and we have x prime plus y prime equals z prime. And we have to divide z to both sides, so we get z prime by itself, and we get x prime plus y prime divided by z. So we plug in what we know, which is 4.1 multiplied by negative 6.45 plus 5.56 times 5.71 divided by 6.91, and we get an answer of 0.77 yards.